Right, Science PSLE Mock Exam 2023. Let me look at your answers as well. Okay, MCQ seems to be pretty okay. Right, I better change the color of all. Otherwise, you'll be thinking, how come different color? Okay, so I changed the red color to something lighter because it's quite painful for the eyes. If you're in the Google Sheet, you know what I mean, huh? Okay, question 1, 2, okay, that it seems like fair distribution. Question 7, maybe. All right, question 7. Probably that is the one you need more help with. So let's look at question 1. I think pretty straightforward. Okay. The stalk of flower, if you remember, in P5, you learn about the plant transport system. Plant transport system, you only need to know about food, you need to know about water. So you also need to learn about the 2 types of tubes. Okay, so what do you learn about the tubes in the plants? What are the 2 tubes that you learned? You might want to quickly type it down. Okay, the faster you respond, the higher the chance of us playing game later, because once I know you are clear, you know what we are talking about, then we can move on quickly. Yeah, wow, now so fast, everybody's typing in. Very good. Okay, yes, Yancy, I saw you already learned the secondary school term. Sean as well. Okay, did your teacher tell you that's not necessary? Never. Okay. By rights, you only need to remember food carrying tube, water carrying tubes, right? Don't have to know the terms xylem and phloem, but you need to learn these 2 terms when you are in secondary school. Okay, so in secondary school, this topic is in Sec 2. You learn about the transport system in plants as well as in human beings again, but more things will come in. You are learning more and more. And if you, let's say, go to Sec 3 and 4, taking up the subject biology, okay, taking the subject biology, that science branch, biology, then you are going to learn even more about the transport system. So it's always building on to your previous knowledge. Okay, Heidi says, is it food hyphen carrying tube or is it food no hyphen carrying tube? What do you all think? What do you all think? Food carrying tube with the hyphen or without the hyphen? With or without? Yeah. Okay, it's a with. Okay, food hyphen carrying tube, Heidi. But if let's say in an exam you wrote down food carrying tube without the hyphen, are you going to be marked down? No. Yancy, you shook your head, but you gently shake it only. I saw. Okay, yeah, you're right. Okay, you won't be marked down. They don't mark you down this way. They are testing for concept. They're not testing you for perfect English, right? So it's fine. So what happened is, if you recall, you did this exact experiment, yes or no? Inside your workbook, there is even an experiment for the celery tubes. And then your teacher would have cut it and showed you, right? The cross section. And you are going to see that the red portion stays red, the blue stays blue. All right. But it's not as if the whole thing will turn purple because red plus blue gives you purple. It won't happen that way. All right. Because why? Because the tubes are like straight, hollow, okay, throughout the stem. Okay, so they'll follow one single path. One tube will have one straight single path to follow through. Okay, so that's why they do not mix color at all. Understand now? So those of you who got this wrong, I hope you understand already. Yeah. Okay, the tubes are actually very straight, like straws. We have also done this as well, right? Okay, they are like straws also. Okay, so they have one single hollow tube from the bottom all the way to the top. All right, Sean, you get it now? Right, so hopefully you don't mix this up. Question 2. Diagram below shows movement of water in the environment. Okay, quickly tell me, for water bodies, what is the state of water? What is the state of water? Type it in. Okay, all right, just a few responses only. Okay, good. Yep. So this is liquid state, right? What about water vapor? Water vapor. Right. You can say that it's a gas or you call it gaseous state. What about clouds? What about clouds? You're sure, Charmaine? You sure? Yeah? Yes, it is in liquid state because clouds are made up of tiny water droplets. Okay, so you need to know this. So now if you take a look from for the table here, liquid to gas, there's only how many? There's only one stage here, right? And that is A, correct or not? So we have A. And then now let's look at gas to liquid. There's only B. So that's why our answer is C. All right. Can see? You understand now? Sharia, understand now? Okay. And then Cassandra also, Bunshen also, I think you did not do this part here. You forgot to write down gaseous state, liquid state, yes or no. If you don't do this, yeah, you would have gotten it wrong. Let me see what do you put down. Sharia, you put down B. Yeah, never mind. Now you know it's actually C, right? I think when you were doing this, you did pretty early and then you probably chose too quickly. Yeah, it can happen. Let's go on to question 3. Now, this is a syringe containing air and some water. Tom blocked the opening of the syringe as shown below. His friend Jerry, Tom and Jerry, okay, pushed the plunger downwards. Now, if you take a look here, okay, this is actually a diagram I inserted in. It is not in your question paper. So these are how gas molecules or gas particles are arranged. They are actually free to move about. There's a lot of space between the particles. That's why, let's say when Jerry pushed the plunger downwards, okay, the particles just come closer together. There's a lot of space. It's just like all of you are standing around your classroom, maybe only 20 of you, perhaps. Then if your teacher say, oh, we're going to half the space of the classroom so that, you know, another half can be given up for something else or for some other classes, then you all just come closer together, right? Still have space, right? Isn't it? Yeah, for you all to squeeze closer together. Okay, but if the teacher half the classroom again, half that classroom size again, then you got to come nearer and nearer, isn't it? So that is how you can try to imagine it. Okay, for gas particles, when they are being compressed, what happens is the particles come closer together, the space between them gets lesser only. So that's what's happening. So if I were to draw, okay, gas particles are like that. And then the liquid particles, I can draw it this way. They are close together, but they are not in fixed arrangement. How many of you already know about particle arrangement? You learn about this for solid, liquid, and gas? Very good. Okay, good. I think even for me, when I went to teach in primary school, I find it so difficult not to show them this. Yeah, because I was teaching in secondary school, right? We were teaching students about particle arrangement in solid, liquid, and gas. So no choice, you know, I had to bring it down to let the primary school students see. And immediately they understood. If I don't use that, it was so difficult to explain. See, now all of you can understand. So what is the answer over here? Answer is A, the plunger moves downwards. Okay, can move downwards because air has no definite volume. Which is why if I put this same amount of gas into a bigger container, imagine I have a bigger container. Do you know that they are just going to spread out and occupy the whole space? It's just like I asked you all to go to the hall. Do you think all of you will actually stay at one tiny portion of that hall? No, right? You all will run around and go crazy, right? Run and play and shout and scream. Correct or not? If you're allowed to occupy a certain space, all of you will be just running about. Okay? Only the shy ones will probably hide in one corner or stay at one place. But the rest of you, usually you'll just be moving all over. Same logic here. Question 4. Okay, Joseph placed object T on a weighing scale. Then the scale showed a reading of 8 units. So it shows the number 8 here. After that, he placed a bar magnet. So this is the bar magnet he's talking about. Okay, 1 cm directly above T. The scale showed a reading of 10 units. Why did this happen? If you know, tell me quickly. Why do you think this happened? All right. Why is this happening? Ian, are you here, Ian? I don't see you. I don't see your responses also. Okay. All right. Right. So I see some of you typing in. Yeah. Very good. More responses now. Okay. Yes, there's magnetic repulsion. Okay. There was magnetic force or repulsion. The light poles are facing each other. So this seems to be like a magnet, right? Since there is repulsion, there is a push downwards. Okay, so the push downwards caused the reading to change, right? And now it is 10 units. Okay, so the force is pretty strong. Light poles are facing each other. Now he flipped the bar magnet over. He flipped the bar magnet over. Okay, now this is the south pole. What do you think will happen between the bar magnet and object T? What will happen? There would be attraction. So if this becomes an open-ended question, you must know how to explain. Okay, so there is attraction. When it is held 1 cm above, that means that metal or that object T will move up. So it's no longer touching the weighing scale. It's no longer touching the weighing scale. It got attracted to the bar magnet, and that's why the weighing scale will give you a 0 unit reading. Clear? Yes, Sharia, you're right. Okay, very good. Let's go on to question 5. 2 circuits using identical bulbs and batteries in working condition were set up as shown. In which circuit would the bulb light up? Okay. Your choice is actually, some of you, let's see, question 5. Some of you got this wrong. Okay. Yeah. Okay. I have all the options there. A, B, C, D. Everybody chose. Okay. So, Sharia, do you know why you're wrong now? And then Battle, you also chose none of the circuits will light up. How come? Okay, do you all see that this is the positive terminal? All right, and this is the negative. Yeah. Okay, so this would definitely light up because you see one wire is connected to the metal tip. Then you have the metal casing with another wire attached to it. So there's a closed circuit here. This will light up. Yeah, but for this case, oh, Shamin, the bulb is cracked in circuit A. The inside is broken. Okay. Is that why, Battle, you also chose D? Is that why? Let me see. Sarah also chose D. All right. So it's broken. The inside is broken. Actually, the drawing is not good. Actually, they are all in working conditions, okay? So the drawing is not good. Okay, Bunshen and Shamin, do you see that inside the question, it is stated that all the bulbs and batteries are in working condition, so they are not broken. The drawing is not good. I will have to apologize for that. Okay, let me tell the tech team they need to improve on diagrams, okay? Yeah, thank you for highlighting this. They are in working condition. So this circuit A, okay, the bulb will light up. But in B, do you see that this negative terminal is connected by a wire to the negative terminal of the battery? When this happens, Remember, I asked you this question before.